Hello everybody, my name is Katie Ballard and today I'm going to tell you a little bit about what I know about enzymes, and hopefully this video will help you understand enzymes as well. First off, I'd like to answer a question that most of you are probably already thinking. Enzymes are catalysts. In other words, they are a protein or RNA that speed up chemical reactions. Enzymes are very specific to the substrates that they bind to. For example, these are our enzymes, and these will be our substrates, also known as reactants. And as you can see, this is a black one, and he has a little black tip at the bottom. And in order for enzymes to work, the substrate, this game piece here, has to bind to the active site, or the groove right here. So they will both bind to the enzyme that they are meant for, and from there, they can catalyze the reaction. There are two ways the enzymes bind. The first way we've already seen is called the lock and key model, which is like a lock and a key. The key, or the substrate, fits into the lock, or the active site on the enzyme, and they fit perfectly. The second model is called an induced fit model, where the substrate may look something like this, but the enzyme may be a little more rounded than the substrate. But it still fits itself in there and binds perfectly with the enzyme it's supposed to. When I thought about enzymes, the game chutes and ladders came to my mind, because substrates, they will go along the board and eventually get to the end here where they complete their chemical reaction. However, in some cases, that may never happen because they'll don't have enough energy, or it just may take years for them to get enough activation energy. Therefore, when the substrate binds to the enzyme, it's like going up the ladders. It reduces the activation energy it takes to get further up the board. So eventually, the enzymes help speed up the chemical reaction or catalyze it. To see it in another way, we will have a substrate that will bind with an enzyme, which will catalyze the reaction to come up with the different products. As a specific example, we will use lactose as our substrate that will bind with lactase. Notice the ASE ending. Most enzymes will have that ending. This will split it up. It'll catalyze the reaction and split lactose into its two monosaccharides, glucose and galactose. Sometimes we do not want enzymes to help with the reaction. In that case, it's kind of like the slides in the game chutes and ladders, so it kind of sets the enzyme back. There are two ways that enzymes can be inhibited. The first is called competitive. As you can see, this substrate and this inhibitor both have black lines, so they are really a lot alike. Therefore, the inhibitor can bind to the enzyme just like the substrate would. And that is what inhibits it, so that the substrate cannot bind. The other way enzymes can be inhibited is called allosteric, which means that another inhibitor comes along and binds to any other spot on the enzyme distinct from the active site and actually completely changes the shape of the enzyme so that the substrate can no longer bind until the inhibitor is released, if the inhibitor ever does get released. Thank you all for watching my video about enzymes. Hopefully you understand a little bit more about them now. Hope you have a wonderful day.